Yan. So we have how many chapters in hydrology? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, hanggang 13. Okay. Balbastro, na-distribute mo ba to in 13 groups?
Yes, sir.
Oh. Sige. Nakikita niyo man yung PDF, no?
Opo, sir, nakikita
Okay.
po.
Sige. Kunin ko lang yung aking pen. Okay, sige. So first, the chapter 1 is introduction, no? So i-discuss diyan yung hydrologic cycle. Alam ko naman familiar na kayo diyan. So yung mga evaporation, 'di ba? Yung precipitation. Yan, no? Kung paano no? Kung paano bumabalik yung tubig, no? And syempre pag may precipitation ka, mapupunta yan sa watershed. Watershed. Nakikita niyo yung yung notepad ko?
Hindi po, sir.
Hindi ba?
Po, sir.
Teka. Share. Yan. Nakikita nyo?
Kita na po, sir.
Okay, sige. So our subject is hydrology. Hydrology. Yan. So, first is meron kayong ano yung unang tubig na subjects nyo? fluids, di ba? Fluids. What's happening? Yan, fluids, and then after that, hydraulics. Which is kasabay ngayon ng hydrology. Yan. So, hydraulics. Then after that, fluids, hydrology, saka mag-water. Yan. May na-miss ba ako? Okay, so nandito tayo sa hydrology part. Yan. Okay. So si hydrology kasi, ang dinidiscuss natin dito yung application ng water in general sa isang watershed. No? For example, yung Marikina River. So Marikina River. Marikina River. San mapupunta ang Marikina River? 'Di ba? Magde-drain 'yan towards Ilog Pasig. Pasig River. Yan. Which ultimately will drain towards Manila Bay. Yan. Tapos may harang dito ng white sand. Joke lang, no? Yan.
Grabe naman yun, sir.
So, makita nyo, no? Yung may portion dyan talaga na, ano, no? Apektado tayo lahat. No? So, ganun ka-importante ang hydrology. And itong Marikina River na to, which ultimately drains sa Pasig River, may source yan. No? May source yung tubig niyan. And we call that the watershed. No? Kung ano yung watershed ng Marikina River. Watershed. Yun yung aralin nyo. No? Or aralin nyo dito sa subject na to. No? How to determine a watershed of a certain water body. Say Marikina River. So see what ang watershed nito is malaki. No? Malaki ang watershed ng Marikina River. Primarily yung Sierra Madre, yan, mountain range. Diyan ang source ng mga yan. No? So babaguhin ko yung itsura. Para say halimbawa ganito. Yan, parang ganyan. Okay? So malaki yung area niyan, no? Yung area. Of course, when we talk about watershed, malaking area, so ekta-ektarya yung pinag-uusapan dyan. And yung watershed na yan, ibig sabihin, pag umulan anywhere sa loob ng watershed, ang ultimate draining point is Marikina River, which in turn pupunta sa Pasig River, then Manila Bay. Parang gano'n, no? Ganun lang yung logic nun, no? In fact, itong Pasig River, even itong Pasig River daw, during a certain period of the year, kapag daw dry season, hindi siya sa Manila Bay pupunta, kundi sa Laguna de Bay. Ito ang Laguna de Bay. Laguna Bay. Parang ganyan. Okay? So, sabihin yung direction niya pala is pwedeng papunta dito or papunta dyan. Yan. Okay? So, how about the naman? How about itong si Laguna Bay? May watershed din ang Laguna Bay. So, magkakadugtong yan. Parang ganyan. Of course, part niya ng Laguna. Yan. May portion ng Cavite. And of course, Rizal. Yan yung pumapalibot sa kanya.
May ano pa kayo? Okay. Na matatabo na.
Search lang ako ng pakita ko lang sa Wag na lang. Baka kasi makopyright ako pag nag-google ako eh. Medyo hesitant na akong mag-google within the recordings eh. Anyway, so ano ko na lang, ipasimplihan ko na lang. Halimbawa, ito yung watershed na sinasabi natin. Yan. It could be, say, meron kang river dito. Itong river na yan, merong mga tributary na tinatawag. Parang pag tinignan mo, parang ano yung dahon, no? Yan. Tapos, there could be another watershed dito. Yan. So, meron ulit ano yan, no? Meron ulit mga tributaries. Yan. So, another watershed here. Yan. Yan. May mga tributaries ulit, no? So, parang ganyan. Okay? Yan. So, ito yung say, this is the Pasig River. This is the Marikina. Yan. Okay, parang ganon, no? So, ibig sabihin, this is another area, area 1, another area 2, area 3. Yan. Okay? So, sa hydrology, pinag-aaralan nyo yung precipitation sa isang area, which we call the watershed or catchment. Tapos, ano yung epekto nun sa catchment? Ano yung kalalabasan niyang Q or what we call discharge? Q equals discharge. Yan. Now, yung Q or discharge, anong ano niyan? Anong units niyan? Sa fluids. Liter, di ba? Liter per second, di ba? Or cubic meter per seconds. So, volume over time. Yan. Pag nalaman mo na ngayon yung volume niyan or yung discharge, i-equate mo na ngayon yan dun sa cross-section ng river. Yan. So, parang dinidiscuss ko na yung application ng hydrology. Kaya natin siya pinag-aaralan. So, once you know the Q, so ito yung ano mo, this is your water, this has Q. No? Ngayon, i-equate mo na ngayon yan sa capacity. No? Q capacity ng river. Since nag-hydraulics pa lang kayo, or sino na ba nakapag-hydraulics dito? May nakapag-hydraulics na ba dito? Alam ko, malamang meron eh. No? So, how do we determine the capacity of a river, of a cross-section? By Manning's formula. No? 1 over N, R 2/3, S 1/2. No? Mumultiply mo yan sa area. Yan. So, this is what now, ito is not hydrology. This is hydraulics. Wala yung pen ko. Yeah. This is hydraulics. Okay? Yan. No? So, si hydrology, ito. Ito ang hydrology. Itong discharge. Si hydraulics, ito. Okay? So, nakita niyo yung what do you call that? Pagre-reconcile ng subject. No? Kaya sabay sila. Kaya sabay niyong kinukuha yan. And that's why, in theory, I will not allow ang students na magtitesis ng walang hydrology or even hydraulics. Kasi marami kang topics na pwedeng i-research for thesis pag meron ka nitong dalawa. Yung water, mapagbibigyan pa natin kasi nga, application ng water. Pero itong dalawa, hydraulics and hydrology, very basic to, importante to. So kung wala ka nitong hydraulics and hydrology, therefore, wala kang maiisip na topic related sa water, related sa tubig. So saan ka lang nakakulong? concrete. Hindi lalalim yung pag-iisip niyo, no? Parang the purpose of research is dapat comprehensive na yung alam niyo. No? Kaya mahigpit ako, no, na hangga't maaari ayokong magtitesis ang student na walang hydraulics and hydrology. Because hydrology is yan na, application na yan, baha, no? Hindi mo malalaman ang analysis ng flood pag wala kang hydrology. And alam naman natin yun ang main problem natin ngayon, no? Floodings. Okay? Ayan, so sa hydrology malalaman nyo ang Q. Yan. Paano na-determine ang Q, ang discharge ng isang watershed at this point, no? Kapag umulan sa watershed niya, say at this point, kailan magta-travel yung ulan na to papunta dito sa point na yan? So kung ikaw, let's say dito ka nakatira, no? So halimbawa si Alcantara diyan nakatira, tapos umulan dito, no, at sa certain intensity, say 10 millimeters per hour na intensity, kailan pupunta sa barangay ni Alcantara yung baha? Yan, no? Diyan natututunan yan, no? At kapag at that intensity, 10 millimeters per hour, babahain ba siya? No? Aabutin ba yung lugar niya? No. So that's the main application of hydrology. Okay? Okay, so balik tayo sa book. Reference natin. Our reference is itong book na to. No? Ito din yung reference namin before kay Linsley. Yan. So yun. So pag-aralan sa chapter 1, the introduction. Of course, the weather. Yan. Siyempre, ang Philippines, maraming weather yan, no? So let's say yung mga portion malapit sa Pacific. So mas madalas ang ulan doon. Therefore, statistically, yung rainfall doon is iba compared dun sa rainfall sa left portion ng Philippines. Ganun, no? Okay. And even the temperature, no? And the wind, of course, yung wind. Kaya nga, makikita niyo sa NSCP, yung wind speed ng bandang Samar is mas malaki compared dun sa design wind speed banda sa Manila. Kasi nandun madalas ang typhoon. Okay. Sa chapter 3, precipitation. Ito na yung ulan. No? Ito na yung ulan. How do we interpret the precipitation data? Ito kahit itong snow cover and snowfall, pwede na natin hindi masyado siyang i-tackle. No? Kasi pang US lang naman yan or other western country. Then, precipitation, syempre yung precipitation na yun, yung ulan na yun, will turn into a stream flow. No? Diba? Pag umulan doon sa watershed mo, magiging discharge siya ng river. So, or what we call stream flow. Yung water stage, yan yung pag-measure, diba? Naalala nyo, ito yung creek or river. Ito na yung tinatawag nating stage. Okay? Yan. So ito yung creek mo. Yan. So if you know this height of water, no? Mako-convert mo yung height na yan into a corresponding Q. Yan, no? Kasi with the parameters of ano lang naman yan, no? Of area, no? Malalaman mo na yung Q. Okay? Which is tinuturo din naman sa hydraulics. Okay? So if you know the Q, mababack calculate mo na ngayon yung naging precipitation dun sa watershed mo. So nakikita niyo yung pagdudugtong, no? Now, yung evaporation and transpiration, siyempre pag umulan, karamihan sa ulan na yon mag-evaporate, no? Pag masyadong mainit. Yung iba naman mapupunta dun sa forest, no? Sa mga puno, no? So sila yung nag-absorb, no? That's what we call transpiration. Yan. Kaya dito pa lang sa chapter 1, na didiscuss na yung water budget na tinatawag. The water budget. So, parang ano lang naman yan, parang summary lang yan ng precipitation, tapos ililess mo yung infiltration, ililess mo yung evaporation, gano'n, no? Yung transpiration. Kasi yung precipitation yung total water, parang gano'n, di ba? Siyempre, some of those precipitation mag-infiltrate sa soil. Kaya may groundwater tayong pinag-uusapan. Some of those water mag-evaporate, no? And some of those water mapupunta sa mga dahon-dahon, no? Sa transpiration. So yan, kaya pinag-uusapan din yan, no? Now, so sa infiltration or sa groundwater, yan. Yung pag umulan, iba doon is mapupunta sa groundwater. Yan. So, yan, napag-uusapan dyan yung how do we compute yung groundwater. No? Of course, syempre yung mga groundwater na yon will later on turn as a source of water ng mga deep well. Yan, no? Deep well. Yan. Sa province, no? Kapag wala silang supply ng tubig, no? Sa deep well sila nag-rely. No? Although, in theory, hindi na siya inaalaw, no? Kasi nga, anong nangyayari? Nagkakaroon ng groundwater subsidence, no? So, bumababa, no? Yung lupa natin, no? Naapektuhan, no? Kasi, alam naman natin, from soil mechanics, di ba? Ito yung lupa natin, ang soil has what we call effective stress, saka pore water stress or pore water pressure or from the water, no? So because of deep wells na nawawala yan, no? So ang natitira na lang sa iyo, 'di ba? Total stress is effective, 'di ba? Plus pore water pressure. So pag nawala yung pore water pressure, effective na lang matitira yung intergranular strength ng soil mo. So nagdidikit-dikit ngayon yun. So such that itong lupa mo bababa. Yun yung epekto nun, no? Pag nawala yung mga supply mo ng pore water's pressure sa ilalim. Okay. Ngayon, yung precipitation sa isang watershed, parang ni-normalize ng mga hydrologists, no? They come up, nag-devise sila ng hydrograph na tinatawag. Parang when we say normalize, parang unit hydrograph, no? Parang ang isang watershed, pwede mo siyang i-represent ang isang watershed ng isang hydrograph na graph. So graph 'yon, no? So parang yan, ganyan, yan, parang ganyan, no? Yan ang hydrograph, no? Kaya nga graph, no? Parang ito na yung fingerprint, no, ng watershed mo, no? Parang pag umulan, yung response ng watershed mo is something like this, no? Tataas yung precipitation, kumbaga ito na yung distribution niya ng discharge dun sa buong watershed, no? Anyway, may mas malalim tayong discussion dyan later on, no? Because if itong hydrograph na to, mapapasimple niya yung tinatawag nating runoff, no? Which is yung mapupunta sa river. Yan, parang gano'n, no? With the hydrograph, malalaman na natin yung discharge. Parang gano'n ang ibig sabihin nun. Yan, so estimating the volume of storm runoff. Yan. So isang reason kaya tayo nag-hydrograph, malalaman mo kagad yung volume ng storm runoff. Let's say umulan, no? Umulan ng Ondoy, di ba? I believe very familiar kayo sa Ondoy, which happens 2009, no? So ang sinasabi nila, the Ondoy is a 100-year flood. When we say 100-year flood, statistically, ang return period niya is 100 year. Or on a layman's term, it happens once every 100. So ganun ka rare yung undoy, no? Maraming nga nagsasabi, more than 100 pa eh. No? Okay? Maraming research, no? Hindi lang 100 year, no? Could you imagine yung ganung 100-year flood pag nangyari ulit, di ba? Nakakatakot. No? So statistically, it happens parang nga, once every 100. Parang gano'n. Yan. So, hydrographs of runoff. Yan. Ito pala yung unit hydrograph. Stream flow routing. When we say route, di ba, nakapag-route surveying na kayo, di ba? Pinag-aaralan nyo yung channeling, no? Yung, sa route surveying kung paano dumadaan, no? Paano gumawa ng daan. No? So parang ganun din. No? Sa stream flow routing, say umulan nga sa ano, halimbawa, sa Marikina River. Yan. Sa stream flow routing pag-aaralan mo, kailan mapupunta sa Pasig River yung ulan galing Marikina. Yun. Ganun yun yung ibig sabihin nun. No? And ganun din sa Marikina. Kailan mapupunta sa Marikina River, say ito yung Marikina, ito yung Pasig, kailan mapupunta sa Marikina River yung ulan galing, ano bang tributary ng Marikina? Sabihin natin, Tayabasan. No? Yung project namin yun dati sa Antipolo. No? We have, pinag-aralan namin yung Tayabasan River. No? So, Tayabasan River is located in Antipolo. So, yung discharge ng Tayabasan will ultimately mapupunta sa Marikina River. So, ganun sa routing, no? Kailan mapupunta sa Marikina River yung discharge coming from Tayabasan? So, pinag-aaralan natin dyan yung slope. Siyempre, yung elevation ng Tayabasan River saka nung Marikina River, kailangan mo ng pag-aralan yan. So, because that will determine yung time it will take na mag-travel yung water papunta sa isang sa downstream, no? When we say downstream, syempre down, no? Papunta doon sa ilalim, no? Ano pa? The slope, of course, no? Syempre yung slope mo is basically yung rise over run, di ba? Yung elevation ng Tayabasan minus the elevation of Marikina River, kung tapos i-divide mo dun sa distance ng dalawang water body. Basically, may slope ka na, no? And then the time it takes. So the time it will take will depend sa cross-section naman no dalawang river, di ba? Syempre, mas mabilis mapupunta yung river, yung tubig kung say mataas yung slope tapos yung cross-section is maliit. Diba? Kasi mas mataas yung velocity. Parang gano'n. Okay? So, next, chapter 11 naman is frequency and duration studies. Yan. So, syempre, pag umulan sa isang watershed, let's say 10 millimeters per hour, ano ang mas babaha? Yung 10 millimeters per hour o yung 5 millimeters per hour? Syempre, yung 10 millimeters per hour, di ba? Mas mataas yung intensity niya, no? But, the question is, yung 10 millimeters per hour, if it happens only, sabihin natin 2 minutes, di ba? Tapos, while yung 5 millimeters per hour will happen 24 hours. So, may ano yon, no? May factor yon. So, dun pag-aaralan yan. Okay? Next is sedimentation. Medyo dito sa sedimentation, to be honest, wala akong masyadong experience sa sedimentation, no? Kasi ano yan eh. Syempre, di ba, pag meron kang river, tendency niyan, over time, magkakaroon yan ng sediments. Yan. So, bakit pinag-aaralan ng sedimentation? Syempre, yung sediments na yan will cause na yung capacity niya will be lesser, no? So, yung capacity niya, say, 50 years ago, no, is greater than yung capacity niya now. So, yung capacity present, no? Mas malaki yung capacity dati because of the sedimentation. Kasi lumiit na yung area mo. No? Yung hydraulic area mo, lumiit na. So, kaya pinag-aaralan yung sedimentation. Okay? Kumbaga, ano yung epekto niya? No? And bakit nagkakaroon ng sedimentation? And natural naman yan, no? Nangyayari talaga yan kasi because yung watershed natin, pababa yan, di ba? So tendency, yung mga erosion, yung mga landslide, no? Yung mga lupa sa taas ng bundok, mapupunta sa ilalim, no? So that will cause sedimentation din, no, sa river. Yan po. So, and then last is yung application of hydrologic techniques. Yan. So, yung sinabi ko kanina, yan, storm drain design, yung drainage ng subdivision, drainage ng city, yan, river forecasting, kung malalaman mo kung kailan babaha sa isang lugar, yan, mga flood control design. So, which is, yung mga yan is already, ano na yan, no? Research project na yung mga yan kung tutusin. So, that's the basics. Kaya kailangan ng hydrology and hydraulics. No? Mapag-aaralan niyo yung basics na yan. No? Okay. May question ba? Before ko i-play yung video nila Balbastro? Wala naman, no? Sige. So, i-play ko nito.
Good day, everyone. I'm Balbastro, and I'll be reporting the Chapter 1 of the reference book, Hydrology for Engineers by Lindsay, Kohler, and Paulus.
Nadidinig nyo? Ha?
Yes po.
Okay, sige. Tuloy ko lang, ha?
Since this is just an introduction to hydrology, I won't be giving you an in-depth discussion, just an overview. So let us define first, what is hydrology? Based on the book definition, hydrology is a branch of physical geography which is concerned with the origin, distribution, and the properties of the waters of the earth. So why is hydrology important in engineering? Engineering hydrology includes those segments of the very broad field of hydrology relevant and applicable to the design and operation of engineering. It is an important field where the people who study hydrology, which are called hydrologists, use their knowledge and expertise to combat water pollution, protect the Earth's water resources, and provide engineering hydrology. This helps engineers in the study of floods, droughts, and a fair distribution of water. The course will introduce us to hydrologic materials and methods such as fluid mechanics, hydraulics in open channel flow, probability and statistics, surface and subsurface hydrological processes. Hydrology is used in engineering mainly in connection with the design and operation of hydraulic structures. What flood flows may be expected in a spillway or highway culvert or in a city drainage system? What reservoir capacity is required to assure adequate water for irrigation or municipal water supply during droughts? What effect will reservoirs and other control works exert on flood flows in a stream? So let us now go to the concept of the hydrologic cycle. It is a point from which to begin the study of hydrology. I believe that we have all encountered this back in high school. This book shows the hydrologic cycle. Heat causes water to evaporate. That also happens in plants and trees. Sublimation is the conversion between the solid and gaseous phases of matter. All that water makes clouds. This is known as condensation. The clouds are transported by the wind. Finally, the condensed moisture falls to the earth as precipitation. Precipitation can be rain, sleet, snow, hail, ice, or fog. When water vapor forms ice, skipping the liquid phase, that is called deposition. Snowmelt runoff flows downward to form streams and rivers. Streams and rivers flow into the ocean in a process called surface runoff. Then there's infiltration and percolation. Groundwater groundwater also flows to the oceans. This is called groundwater. And then finally, plants absorb water from the soil. This is called plant uptake. It is precisely these extremes of flood and drought that are often of most interest to the engineering hydrologists. For many of our hydraulic engineering projects are designed to protect against ill effects of extremes. Thus, we are not just concerned in obtaining a qualitative understanding of the hydrologic cycle, but also in measuring the quantities of water in transit in this cycle. There are various of factors to be considered. Let's now go to the history of hydrology. Around 3000 BC, based on archaeological evidence and Mohenjo-daro, people that time have good knowledge of groundwater developing through wells. And during this period too, the oldest dam was constructed across the Nile River. Then around 300 BC, Aristotle stated that all the water comes from precipitation and gets collected below the surface and emerges as the quantity increases. And later during the civilization development, people learned many principles of hydrology, and they started constructing dams, reservoirs for storing rainwater. In 14th century, Leonardo da Vinci states the principle behind the flow in open channels. In 15th century, Bernard Palissy stated that the rainfall is the only source of water for rivers. He and Leonardo da Vinci provided the concept of the hydrologic cycle. Then comes the 17th century. Pierre Perrault-Marient and Halley were the pioneers of modern hydrology. Pierre was the first to propose the concept of rainfall measurement by water balance equation and catchment area method. Halley was the first to measure the evaporation in the Mediterranean Sea. But however, the instrument that he used is still a mystery. And in 16th century, the piezometer, Cesi's formula, rain gauges, and etc. were modernized during this period. And at the end of the 19th century, rapid advancement was made in instruments for acquiring rainfall, groundwater, runoff data, and etc. And that's the end of my report. Thank you.
Tapos na pala. Ka.
17th century, Pierre Perrault chose the hydrologic cycle. Heat causes water to evaporate. That also happens in plants and trees. Sublimation is the conversion between the solid and gaseous phases of matter. All that water makes clouds. This is known as condensation. The clouds are transported by the wind. Finally, the condensed moisture falls to the earth as precipitation. Precipitation can be rain, sleet, snow, hail, ice, or fog. When water vapor forms ice, skipping the liquid phase, that is called deposition. Snowmelt runoff flows downward to form streams and rivers. Streams and rivers flow into the ocean in a process called surface runoff. Then there's infiltration and percolation. Groundwater also flows to the oceans. This is called ground flow. And then finally, plants absorb water from the soil. This is called plant uptake. It is precisely these extremes of flood and drought that are often of most interest to the engineering hydrologists. For many of our hydraulic engineering projects are designed to protect against ill effects of extremes. Thus, we are not just concerned in obtaining a qualitative understanding of the hydrologic cycle, but also in measuring the quantities of water in transit in this cycle. There are various of factors to be considered. Let's now go to the history of hydrology. Around 3000 BC, based on archaeological evidence at Mohenjo-Daro, people that time have good knowledge of groundwater development through wells. See, Aristotle's quantity impact, and they started measurements for acquiring rate.
Okay, so sino ang group 2?
Ako po, sir, Alcantara
Kayo Alcantara. Weather and hydrology.
po, sir.
Wala pa kayo?
I-upload ko mamaya, sir. Ano na po, editing pa rin po, sir. Medyo mahaba rin po.
Okay, sige. Ganito, para may activity kayo, so nag-search ako, no, Marikina River Catchment Area. Nakikita nyo?
Opo.
Yes, sir.
For sure naman, hindi lahat kayo under dito eh. No, siguro, kung saan yung current location nyo ngayon, hanapin nyo kung saan catchment area kayo. No? So, identify nyo yung location nyo, saan kayong catchment area. For example, halimbawa, ikaw Alcantara, nasan ka ngayon?
Nasa Cavite po ako, sir.
Cavite. So i-click ko tong Marikina River Basin. Yan. Ano ba to palalakihin? I-click ko ba to? Yan. So malayo ka sa ano, no? So ito yung catchment area ng Marikina River Basin. Yan pala, yan. Rodriguez, Rizal. Yan, Rizal, Antipolo. Kagaya yung sinasabi ko sa inyo. Yan. So ito yung catchment niya. Okay? Yan. So, ibig sabihin, pag umulan dito, ultimately mapupunta dito. Ganun yung, parang ganun yung sabihin nun, no?
Opo, sir.
So, halimbawa, Cavite, ano bang catchment mo? Okay.
Po ba, sir, Laguna Lake po ata?
Malamang Laguna Lake, no? So, at least, gusto kong magkaroon kayo ng awareness, no? Kung saan yung catchment nyo. Ba, pag bumaha sa inyo, at least alam nyo anong source. No? Ibig sabihin nun. No? So, meron bang taga Marikina dito or taga Rizal, taga QC na apektado?
Sir, nasa Antipolo po ako ngayon.
Sino yan? Si Balbastro?
Prieto po.
Prieto. O yan. So, nandito ka. No? Ibig sabihin,
Opo.
pag umulan dyan sa inyo, yun, magpo-contribute ka ng baha sa Marikina. Yun ibig sabihin nun, no? So, ang gusto kong gawin nyo din is, yun nga, i-attach nyo, lagay nyo yung location nyo, anong catchment kayo kabilang, At ano yung area niya? Anong area ng catchment na yon? Yan. Basically, ganun lang. Tapos, picture. Picture yung catchment niyo. Tapos, siguro, 2 paragraphs lang, no? Sabihin nyo, as an awareness, bilang citizen, ano yung epekto ng baha ngayon, no? Sa ano nyo, sa buhay nyo, no? Parang, for how many years kayong nakatira dyan, di ba? Ano yung nakikita nyong problem, no? Problem dun sa lugar nyo na dapat i-solve. Tapos, how to solve, no? Solution. Ganun lang naman, no? Para lang, ano lang, parang diagnostic exam lang, no? So, at least, alam nyo yung problem, kung meron man, ano yung possible solution na naiisip nyo. And habang inaaral nyo itong hydrology, mas magiging malinaw sa inyo. Ano yung proper approach. Okay? Sige, yun lang naman. Ito lang, no? Then, halimbawa, Laguna Lake, no? Sige, search natin sa Google. Paano ba Google? Naka-incognito kasi ko. Google. Laguna Lake catchment. Images. Ito naman ang Laguna Lake. Ayan, ganyan kadami. Mas maganda kung ano nyo, no, let's say si Prieto, nandito siya pala, no? So ma-identify nyo anong creek yan, no? Saan siya mapupuntang creek, ang papuntang Marikina. Parang ganon, no? Kung ma-identify mo yung creek na yun. Okay. Tinig ko na. Ito pala. Yan. So this is the Pasig Marikina Laguna de Bay Basins. Yan. So Laguna de Bay, ito pala Marikina. So nakikita niyo yung delineation. Yan. Yung mga delineation. Yan. Okay, ito. Yan yung Marikina. Okay, yan. Okay. So si Laguna, yan, karamihan ng Rizal, no? Ito. Magde-drain papuntang Laguna. Ito. Yan. Pagsanhan, Santa Cruz, Calauan, yan, San Cristobal, ito San Pedro Laguna, hanggang Parañaque, oh. Muntinlupa, ano to? Anong lugar to? Ilalim ng Parañaque. Cavite ba yan? Muntinlupa, Las
Po, sir,
Piñas.
Imus po.
Imus to. Imus ba? O yan, Cavite. O, nandiyan ka ba, Alcantara?
Po, sir, dyan po.
O, yan. So, ibig sabihin, catchment mo ito, magde-drain kayo papuntang Laguna de Bay. Kaya ano, no, pansinin niyo, no, sinama sa catchment yung Pasig. Kasi nga, yung sinasabi ko kanina, sometimes, depende sa araw, depende sa season, yung Pasig nagdi-drain din kay Laguna. So, ganyan kalaki. Okay? Yun. So, identify mo yung location mo. Halimbawa, Alcantara, identify mo sa Imus, anong creek malapit ka doon, tapos, ayan, mas maganda, pati yung distansya, no? Ayan. Papunta, so most likely kung nandito ka sa Cavite, magde-drain ka papunta saan? Dito yata, yan, papunta doon saan? Okay? Yan, so what else? Ano pa mang nearest body sa atin? Kami sa Valenzuela, andito ako. Tulyahan, yan, andito kami. Kaya pag umulan sa Lamesa Dam, I think ito yung Lamesa Dam siguro. O ano yan ang Lamesa Dam is overflow dam yan no? Wala siyang gate. So hindi siya may iwasan. Talagang pag nag-overflow siya, tuloy-tuloy lang siya magde-drain papuntang Tulyahan River. So si Tulyahan, yan yung nagko-cause ng floods naman sa Valenzuela. So andito naman kami. Okay? So yun, get the area. Yan. Kung kakayanin nyo makuha yung area ng creek nyo, maganda, no? Pero nakigets nyo yung relationship, no? So, on your location, pwede nyo actually mahanap yung area na magko-contribute sa flooding sa inyo. No? Iba yung area ng buong catchment, iba pa yung area ng bawat creek na yan. Itong creek na to, yan, meron din yung area. No? Na pag umulan, yun yung sakop niya. Okay? Sige. So, para ano lang yan, para lang ma-brainstorm kayo. No? At least maging aware kayo sa tinutuntungan yung lugar. No? Kung bakit binabaha. No? Kumbaga, pag umulan sa inyo, alam mo dapat na hindi ka apektado ng marikina. Parang ganun. Okay?
Pero paano po yun, sir? If, parang dalawang bodies of water po yung nakaka-epekto po sa amin. Kagaya po sa Cavite, pwede po yung Laguna and pwede rin po yung Manila Bay.
Sa inyo? Sa Cavite? Ganun
Po,
ba sa
sir.
inyo? Oh.
Ano po, sir? Malapit din po kasi kami, sir, sa may Manila Bay po. Ganun.
Okay. I think hindi. Kung malapit ka sa Manila Bay, malamang hindi ka sa Laguna nagde-drain. Papunta ka siguro sa Manila Bay. Malamang ganun. I think ito yata, ito. Sorry yung mali yung arrow ko. Yan, itong mga to, yan. Manila Bay na yan.
Opo, sir.
Yan na
Opo,
pala. Yan na, sorry, yan. Yan na. Yan. Kasi ang title nitong image is yan, no? Pasig, Marikina, Laguna de Bay Basins. Eh di ang i-search mo naman, Manila Bay Catchment. Try natin Manila Bay Catchment Area. Manila Bay Catchment Area. Images. Land use up. Ano to? Ito, Marikina to eh. Okay. Tingin ko kung malapit kayo sa Manila Bay lang siguro kayo. Okay. Water, Metro Manila. Tingin ko nga ito. Yan. So, banda dito kayo, dyan? Malamang...
Opo, sir. Banda dyan.
I think, Manila Bay lang yan. Baka hindi na kayo kasama ng Laguna. So, yun nga. That's din, no? Parang you sort of research din, no? Para alam mo din, no? Doon na papasok yung research na sa location mo. No? Naka-apekto ba kami sa Laguna or directly kami kay Manila Bay? See? Pero most likely Manila Bay ka lang. No? Kasi as I remember, take note, ang humihiwalay dito, alam niyo kung ano? 'Di ba yung Makiling? Yan, nandito ang Makiling eh. Nandito ang Makiling. Yan. Dahil sa Makiling na yan, some portion ng Makiling papuntang Cavite, papuntang Batangas. Yan. Yung side na to ng Makiling, itong side ng Makiling papuntang Laguna de Bay. So, yan, na-delineate ko na rin kasi dati yung Makiling Mountain eh, no? May portion ng Makiling na papunta sa Batangas, may portion na papuntang Laguna. So pag umulan dito sa south part, Batangas papunta, all the way hanggang Taal. Yan. Pag dito umulan naman sa north part, papuntang Laguna de Bay. Okay? So malamang kayo ang magko-contribute papunta kay Manila de Bay sa side nyo dito. Okay? Sige. So yun lang. What else? Siguro yun. So yun ang activity nyo for now. Along the way, tuturuan ko naman kayo mag flood analysis, basic flood analysis para maano. Okay, may question ba? So sa group 2 mag-upload na lang mamaya. Yes?
Ask ko lang po kung paano po magiging grading system natin.
Okay, sige, i-discuss ko na lang mamaya, no? Siyempre, major part yan, reporting. Reporting, exam, attendance, gaya na sinasabi ko sa iba, medyo hindi ako maghigpit kasi nga online tayo, no? Naiintindihan ko na yung iba malamang hindi makapag-live, no? So siguro ano lang, dapat at least once a month makapag-participate ka. No? Yun ang ano ko doon, no? At least once a month, no? Tapos recorded naman yung mga lecture natin eh, no? So
Ay, sir, si Carpio po pala, nag-chat na. Sabi niya daw po, idadrop niya na lang.
okay, so what else? May other question pa? So, upload mamaya yung group to, no? Weather and hydrology. No? So thank you din, group 1, for the upload. No? Okay.